Good afternoon. I'm Robert Schwentker. Thank you all for being here. Thank you for STC. Thank you also for Fouad and the Lamarco organization for bringing me here. And also some guests have joined us. Thank you for coming. I'd like to talk to you today about a very big topic. It's a blockchain technology and also the distributed ledger technology. And what is this blockchain? So throughout the next couple of hours, we'll be doing a couple of exercises. So I might have you go to a website on your phone to take a look at a blockchain. I would like for those of you who can download an app on your phone to download an app where you'll get to experience some cryptocurrency on a blockchain on your phone. So we'll do that a little bit later. The app will be for Android as well as iOS. I'll give you the instructions for that. It's called Copay, C-O-P-A-Y, in case you're anxious to download it. We'll have a couple of other people in the room. 5 or 6 of them will be helping us. We'll be giving you some cryptocurrency testnet coins on your phones that you can experiment with. So with that, I'll be talking about what is the blockchain technology, what is the blockchain startup ecosystem, what is this thing called cryptocurrency, what are governments doing with this cryptocurrency. So I have a background working at Citigroup, American Express, PayPal. When I was at PayPal, I was starting to do activities in the Bitcoin and blockchain space. And I broke off and I got together with a couple of VC-funded blockchain startups. And we created something with a great big name called BlockChain University. And it was a small project that we ran for about a year. And it's really no longer operational. But BlockChain University took us around the world, training just hundreds of people on blockchain technologies, both technical people and non-technical people. The strong educational commitment I have to teaching blockchain technology is that you need to apply it. You need to create a project. So our courses have always, and continue to be, the courses I give, are project-based. You build something with a team, and typically a team of technical and non-technical people. So I've created something called Distributed Ledger Technology Education, and we've just continued to work globally with a number of clients. We were in Singapore with Standard Chartered Bank recently, at the MIT Media Lab doing a cryptocurrency boot camp for women and underrepresented people in the US, university scholars. And we're about to do the Cisco Blockchain Innovation Lab in the San Francisco Bay Area. And a number of our instructors here that I work with, I was recently in Japan. This is a couple of the ministers in the IT strategy and payments space at the Liberal Democratic Party in Tokyo. This was our work in Singapore, both technical and non-technical classes, and also at MIT Media Lab. So again, we'll talk about what is blockchain and cryptocurrency, what is this startup ecosystem, things around transactions and cryptocurrency, and what are wallets? What's a wallet in this blockchain space? Well, it's on your phone, but it can also be on a browser. Closer. Better. And then we'll have some activities. So what is a blockchain? If you define it, you can think of it as a cryptographically assured database or a data structure. And that data structure lives in a cloud or in a P2P network. And the transactions on that network are secured by cryptography, and they're tamper-proof. And this is a very profound computer science discovery, that you could do this. And there's proof of it having been done in a new way. For some of the technical people, you may think of this as a reverse linked list. That's essentially what a blockchain is. We'll make some other analogies about what a blockchain is. But we typically take 5 days to explain what a blockchain is and the technology and the ecosystem. So it's something that generally most people still find it hard to grasp what is a blockchain, even after a few hours. Okay, so I see this as a journey where you continue to expand your knowledge. So you can also think of it as like a Google Sheet. You might have used a Google shared sheet, or Microsoft also has some of the shared Excel types of a file where many people on the network can view that same ledger. So think about this ledger, though, in such a way that you can only append one row at a time, and all the rows above it or below it are no longer editable. So one row is written by one computer on the network at a time, and after that, you can't change that record, essentially. If you think of the Google spreadsheet analogy, what I've done here is I've put some real live blockchain explore data here. And we'll explore this a little bit later. There's something called the block height. That's the number of blocks in the blockchain today, and for the Bitcoin blockchain. So we'll talk about what is Bitcoin and what is blockchain in 1 minute. But this is an example of the Bitcoin blockchain. And there are over 400,000 blocks in that particular blockchain. So again, a blockchain is a data structure. And it's been used by a cryptocurrency called Bitcoin. And this Bitcoin cryptocurrency, it's a money, right? It's a money that's being used today. And the market cap of that is 20 billion. I'll repeat that later. But in 2009, you'll see the date here, January 3rd, 2009, this system started. Practically nobody in the world knew what was happening. This brand new system that demonstrated the power of blockchain. No one had ever heard of blockchain at that point. And in fact, there had been experiments with cryptocurrencies over the years, over the decades. A lot in the Silicon Valley, crypto cash, hash cash, various kinds of gold, that they're digi-gold that they're trying to explore. But this is the first block in this blockchain. Oddly, it's named block number 0. And there was a transaction in that blockchain, and a bunch of Bitcoins were created. Turns out Bitcoins are created approximately every 10 minutes. So Bitcoin is a cryptocurrency that uses blockchain to record the creation of the Bitcoins and the transfers of the Bitcoins. Okay, so later on, we're going to create a wallet app, and we're going to give you some testnet Bitcoin to play with, to trade. So it's because of Bitcoin that the concept of blockchain is known. And another difficult concept to grasp is the fact that this system has no central authority per se. There's no central bank that's running this Bitcoin cryptocurrency system. It's a decentralized system. And so there's no banks officially involved. There's no like IBM or Microsoft that's controlling the code. It's random people spread throughout the world that are maintaining this network. So when we think about like blockchain technologies, when you think about, well, can we just set up a blockchain inside of our company? There have been some examples of this, but largely this technology is to be used between your company and other companies. It's like the internet, right? Like you just had an internet. It wasn't like so interesting when you were just using your own intranet, right? It's like a fax machine. You can just like fax somebody. But if you can fax somebody across the world in another company, that's very interesting. So this technology is a network technology between organizations. In the case of Bitcoin, there's really no official organization involved. Maybe you could consider the software developers a loose net organization. We'll talk a little bit more about that later too. So the technology, though, that's very interesting underneath Bitcoin is this blockchain database or data structure. So you have some homework. In 2008, there was this mysterious unknown person called Satoshi Nakamoto. And he created a white paper. It's about a 12-page white paper. If you need to get to sleep really fast one night, just start reading it. You might fall asleep. It's very dense, very technically dense. In the beginning, there's a short paragraph. I highly recommend you read it. It talks about what is this cashless system, peer-to-peer cashless system. It's right there. That might be on the test, so we'll see. There's some test questions from there. Blockchain is not Bitcoin. They're separate and distinct concepts. Bitcoin is a cryptocurrency. Blockchain is a data structure, a decentralized data structure. There's no central authority typically in blockchain systems. It enables Bitcoin. And we see blockchain also called a shared ledger, or even a distributed ledger. The reason I talk more about distributed ledgers today is when you think about Internet of Things devices, those things typically would write something to maybe like a transaction chain, where individual transactions are just appended to a chain, one after the other. In the Bitcoin world, transactions are grouped up, and you'll see hundreds, if not thousands of transactions in a block that occurs every 10 minutes. So if you think of it, there's a database called a blockchain, and a record gets created in the database every 10 minutes, and inside that record, there's 1,000 transactions or 2,000 transactions. That's kind of blockchain technology relative to Bitcoin. In August of 2016, the World Economic Forum created a paper with Deloitte Consulting called on blockchain, and it talked about blockchain will become the beating heart of the global financial system. Profoundly alter the way banks do business. That Bitcoin is kind of a threat, but also the blockchain is kind of a threat with the Bitcoin, but also an opportunity. And that would lower fees, transaction fees, settlement fees. And that to realize the benefits, you would have to collaborate amongst institutions to see it. It's not a siloed application that you would use inside of one organization, typically. So yes, you have some homework here to take a look at that paper. They wrote a paper about several months before that, I think April in 2016, and they talked about how blockchain was one of the six most important technologies of our time. So let's talk about Bitcoin, because Bitcoin is really the only global application today that tells us what a blockchain is. It shows us the power of it. It has a market capitalization of over $20 billion. And it's not been significantly hacked. No one's hacked this thing. How can that be? How can you have this code running on the internet and it's worth $20 billion and no one's been able to hack into it and steal money from it? It's what we call the biggest honeypot on the internet. Honeypots are like you try to hack into a bank and see if you can get $1,000 out of somebody's account, right? It's a honeypot of $1,000. This is a honeypot of $20 billion. Anybody in the world with an internet connection can potentially hack that, but it's not been hacked. That's a profound technology. The network on which it runs is also a profound thing. There's tens of thousands of computers running this Bitcoin network. And if you think about the world supercomputers, all the power of the some 500 world supercomputers, if you put all that computing power together, is it bigger than the Bitcoin network of these 10,000s of machines? Yes, it's bigger. By how much? 13,000 times the world's supercomputers put together. This was something that The Economist magazine reported in 2015. A colleague of mine, Ryan Charles, one of our instructors, recalculated that recently. You can see the hash rate of the network. He calculated it and made an estimate. It's still this powerful. And the fact that this software is open source. You can download it. You can simply just download it. It takes you 5 minutes to download it to your laptop. And you can actually start running it and be on the network and participate on the network. Today, we're all going to download an app. that'll connect us to the Bitcoin network, just like that. Zero barrier to entry in a sense. Anybody can participate. So for those of you who are a little adventurous, you can also download the Bitcoin software. There's a switch on there that turns on the mining function. Mining is a huge topic. It has to do with maintaining the network. It typically takes a couple of hours to explain, so we won't be doing it in this session. But miners are the machines on the network that are maintaining the network. And among them, all the tens of thousands of machines, every 10 minutes, one of those machines creates a new block on the blockchain. So, the blockchain can be explored by various browsers called BlockChain Explorer. And one of the most important ones, I think, is blockchain.info. It's a startup based in London. They've had some significant funding. I think it's in the $20 to $30 million of range of funding. And they have this explorer that allows us to explore the blockchain. And we'll be doing this in a second together. But again, you'll notice the height of the blockchain, how many blocks are on the blockchain today. You'll notice that they're getting created in this case, every few minutes, a new block is getting created. 36 minutes, 24 minutes, 28, 24, 23. The number of transactions in each block from 800 to 2,000. So each block has that many transactions. So if I send you a Bitcoin, or a half of a Bitcoin, or a tenth of a Bitcoin, or $10 million worth of Bitcoin, that's considered one transaction. This is the number of Bitcoins that were sent. And then you can actually see the computer or computer group, because now these things are mined in pools or maintained in pools of computers, like clouds of computers, if you will. And it'll tell you which group of computers created those. And for you advanced people in the room, they actually typically write the name of their mining pool into the op return. So those coins actually get watermarked, in a sense, by the miners themselves, interestingly. Each block is approximately a megabyte. So the blockchain is growing at about a megabyte every 10 minutes. And today, these 450,000 blocks take up about 100 gigabytes of space. So you need 100 gigabytes on your laptop in order to download the blockchain. And it might take you a couple of days or sometimes a few weeks, depending on the internet connection. So another thing you'll see here are latest transactions. You can see the various transactions flowing on the network. You can dig in and see the amounts. This is super profound. How is it that we can see literally thousands of dollars being transferred globally from one pseudo-anonymous person to another? Because we don't really know who these people are who are sending and receiving Bitcoins when we look at this. We don't know who they are, per se. But you can see all this. It's based upon open source code, and it's worth $20 billion. And it's on this massive global computer network that we've never seen before on the planet. So, get out your phones if you'd like. Get out a browser. We'll go to blockchain info. You can take a look at the number of blocks that we were talking about. You can dig down and see a transaction. You can see all the transactions inside of one block. Then you can start to see the amounts. I'll give you about 5 minutes here, and then we'll stop on this. If you're a little bit more advanced, you've done this before, you can check out BlockCypher. They have an interesting blockchain explorer. Something we won't be talking about much today at all, but I just want to point this out. There's many types of these Bitcoins, these alternative currencies, these digital cryptocurrencies. And the second most famous one after Bitcoin, does anybody know what it is? Ethereum. And Ether is the token or the coin. Ethereum is the system. And it's a very different type of system. There's something around smart contracts, code getting embedded into the blockchain. It's fascinating. There is some code getting into the blockchain here. There's things like multi-signature wallets we might talk about a little bit later, and time-locked transactions and things of that nature. So you can do some types of blockchain smart contracts in Bitcoin, but you also have them built in natively with Ethereum. So advanced people, you might want to check out Etherscan. That's a blockchain explorer for Ethereum. But please, if you've never seen the blockchain explorer itself, let's take a look at that on your phone. Go to blockchain.info. There's no .com here. It's .info. On your phone, it'll look a little bit differently, of course, responsive. And just take a look at the number of blocks. Click down and see what's inside of a block. See some transactions. You're looking at the live blockchain. These are real monies being sent between people. Is anybody stuck or have a question? Take a couple more minutes. What is the value of the Bitcoin is the question. There's a number of places to see it. It's approximately, in US dollars, $1,200. So in SAR is close to 5,000, I guess. Something around that. Yeah.
So the block reward for the last transaction is 12.5 Bitcoin.
Yeah.
Now obviously that's
Yes. Yeah.
So why is that? So what does that depend on?
Okay. This is a complex and in-depth question. And he's talking about the block reward. You can see that when you open up a block, you'll see the very first transaction is called the Coinbase transaction. Coinbase is also a startup, which we'll take a look at later. And they were named after what Satoshi Nakamoto in that white paper, he wrote this thing called the Coinbase transaction. So every 10 minutes, a miner is rewarded for maintaining this network. They're rewarded by giving Bitcoin to them. So the network has a game, it has a game, gamification, or a game motivation. There's a motivation for them to maintain the network because they can potentially get the block award, which today is 12.5 Bitcoins. Times $1,200, do the math. It's significant dollars every 10 minutes are entering into the network. That's the economics of the network. So it turned out when the software first started out, and what we saw earlier when we looked at that first block, that the block reward used to be 50 Bitcoins rather than 12.5. Every 4 years, every 4 years, yes, this number goes into half. So this started in 2009. In 2013, January, it went to 25 Bitcoins were given to one of the miners on the network every 10 minutes. And then very recently, that was cut in half again. So 12.5 Bitcoins are given to the miner for creating the block every 10 minutes, plus transaction fees. So if I send you $1, $10, $1,000, $1 million, $10 million in Bitcoin, the transaction fee is about the same. It's approximately 20 to 50 cents. This fluctuates. And for various reasons it fluctuates. It depends on the wallet. And maybe the user will actually specify a higher transaction fee to get it on the network faster. This is profound. The banks took notice. How are people sending $10,000 across the planet and these transactions were seen by everybody instantly, and the person receiving it could actually spend it within about an hour, and it cost them a quarter, 25 cents. How is that? The banks woke up. They're like, oh, we better do something. And they've started to do some things, some very interesting things. But it was a huge wake-up call. Like, how is this happening? So you see a lot of what's happening with the banks is they've decided, well, we need to invest more into technology. We need to make more experiments. We need to get together. Even though we don't like each other, we still have to get together and figure out maybe we can use this to lower everybody's costs. In the case of a bank, know your customer, the KYC, is increasing about 50% per year. And there's no benefit to anybody for all of this know your customer KYC compliance stuff. It's costing 50% more per year. Can we just lower that number? That's why people are looking at this technology. How can we lower this number? Does that answer your question?
Yeah, I mean, I have a follow-up if you don't mind. So, correct me if I'm wrong, isn't there a fixed number of Bitcoin?
Yes, there's a fixed number of Bitcoins today. And there's nothing, thank you, because in approximately 2,140, probably won't matter to anybody here, there will be 21 million Bitcoins issued. If we leave the software alone, we talked about this open source software. Open source software that you can download today. This is review. Let's see. We'll go to here. So this is open source, which means people can suggest changes in the software. Someone can say, well, you know, I want 42 million Bitcoins to be issued, for instance. Or I want the mining reward to go back up to 50. Though everybody has to agree, though. The miners who are running the software have to agree. The developers who are largely in Silicon Valley, some in the US, some in Europe, some in China, some in Russia, other places. Okay? So things can be changed because it's open source code. So we did this lab. Any other questions on this? We can save questions more towards the end too, but I'm happy to take one more. Please. The distribution of the
device, the computer. Who owns these computers? And is there any base for these computers, for example, in the United States or Europe or somewhere else?
Yeah.
Is there any organization, official organization that controls the issuance of these coins?
Very nice question. So the question, if I understand it, is there any central organization who controls the issuing of these Bitcoins or the maintaining of these computers as such? No, interestingly. And that's the profound nature of it. And this is why it's hard to understand. Because there's no central authority saying, oh, now it's time to give 50 Bitcoins out, or 12 and a half as the case is today. It happens because of the software. And the miners, anybody can join the mining network. You can just turn on your computer. Used to be you could mine Bitcoin with a laptop. But then it wasn't efficient. It burned too much electricity. The thing would have to be running for too many days before you could get any Bitcoin. Then you could use your graphics chip on your computer to mine Bitcoin. People were doing that. Then they've created a chip called an ASIC chip, ASIC, that's now used in special computers to mine the Bitcoin. And anybody can join the mining network. Typically now, we would, like if we all wanted to mine Bitcoin, we would all do it together. And then we would have a better chance at getting one of those mining rewards, and then we would just divide it up based upon our computing power and such.
Once you find a Bitcoin, where will you recover that Bitcoin?
It goes into the miner's wallet. So this software, when you download it, creates on your machine the Bitcoin software with the blockchain and a wallet and the capability to talk to the peer-to-peer network through the gossip protocol, as well as consensus rules, the mining rules, the algorithm to try to solve the mining puzzle, and the option to turn on mining. This is a very important question. Is it possible that we have the same Bitcoin in two wallets somewhere on the network, as it were? One of the most profound things that this software did was solve what's called the double spend problem. This was a question when PayPal came out. So what is this PayPal thing? And am I going to be putting money into my PayPal wallet, but someone else is going to be copying my money? Or is PayPal going to copy my money? Or how does that all work? Well, in the Bitcoin world, they've solved what the computer science problem called the Byzantine generals problem. So let me talk just a second about Byzantine generals problem is, let's say we're an army and we're trying to attack a village and we're in four different corners and we're trying to attack this village in the central. Well, how can the general over here tell that general over there, hey, we're going to attack at 6 a.m. in the morning? He sends out a guy on a horse, you know, and he's going to go over there. But somebody on the stops him and says, hey, you know, I'll give you $1,000 and 50 camels, and you'll tell him you're going to attack at 6 a.m. at night. So he goes over there and gets the camels and says, oh, we're going to attack at 6 a.m. at night. Comes back and says, oh, yeah, we're going to attack at 6 a.m. in the morning. So all these guys run in and they all get killed. So the Byzantine generals problem is that there was no consensus in the network. We didn't have agreement in the network when we were going to attack the village. That's the Byzantine generals problem. In the computer network, the computer science problem is how do you get machines on the network to agree that the ledger, the database, the Google spreadsheet, it's the same one. And that the coins issued on that are not being copied, digitally copied. You can make a digital copy of anything, but the network will detect it. So if I send you a Bitcoin, a half a Bitcoin, I can send you a micro Bitcoin. I can send you a penny, which gets very interesting when you talk about computing. Like, how can you pay somebody a penny on the internet? It's never been done. You can do it with the cryptocurrencies. So I pay you a penny. I also pay you the same penny. Oh, the Bitcoin network will detect that. If I send you a Bitcoin, and I also try to send it to you, I have two wallets. I've got a wallet app here. I've got a wallet here. I've copied them. I've taken this other phone. I send it to my friend in Australia, and I say, okay, at 4 o'clock, we're going to click go, and we're going to send that same Bitcoin to two people. Well, if I were sending you a Bitcoin and we were in person and you gave me some goods and the same thing happened in Australia and gave you the goods, somebody will lose, right? But if we were all watching the network and said, no, hold on, I'm going to wait 1 hour before I give you the goods. I want to make sure it's proven. Then one of these transactions will fail and only one will be accepted by the network. I didn't hear. It's not real time in the sense that typically one must wait about an hour or 6 blocks typically before a transaction is confirmed. Depends on the size of the transaction, but that's the general rule. This is not a centralized system. It's a global. It's kind of an ad hoc system. So the rules are blurry and intentionally so. Someone asked me a little earlier, just a second, about why was this thing even created? And it's an important question. And there's a bunch of those kind of hippie people over there in the Silicon Valley, you know. Even some of those startup unicorn founders have been hippies. They're kind of like, and some of these people identify with themselves as anarchists, like crypto-anarchists. I wasn't one of these people, but anyway. And the crypto-anarchist said, you know, why can't I transfer value to you directly without an intermediary? You know? Like, why can't, like, you want to sell me a book. Why can't I just pay you? Why do we have to, like, write a check or, you know, it's like, can I give you some gold? Like, you probably would take a gold coin because they're like, wow, gold, fine. It's like cash in that sense. But how can we do that 5,000 miles away over the internet? It takes forever. Money's a problem on the internet. It takes forever to send stuff. So this group called the crypto-anarchists said, like, why can't we use our knowledge in computer science, cryptography, game theory, economics to create a system that solves the double spend problem, solves the general Byzantines problem, and allows me to transfer money over the internet without a central authority. That's why Bitcoin was invented. We'll take one more question, we'll move on. Loud.
You mentioned that there are scale effects to mining. You talked about ownership technology. So my question is,
Thank you.
my question is, so is it possible for a single entity to control a significant fraction of the mining capability, and what would happen if somebody controlled a majority of that mining
This
capability?
could turn into a wonderful day-long discussion. In fact, it's been going on for months, actually years, the question on scalability of the Bitcoin network. It is possible, something they call a 51% attack. So if someone controls 51%, some people have said 33 could do it, but 51% of the mining power, they could take over the network and reverse transactions and put in only the transactions they want and prevent other transactions from getting in. But then the whole network would see that, and they go, well, why are we playing this game? Like, let's play fair, guys. And today, for about 10 years, we've been playing fair. So the scalability is a different question. It's being fought tooth and nail by many people in the ecosystem, including the miners, the software developers, people who have a lot of Bitcoin. This is an issue. We can take the rest of that one offline. Okay, so we did our lab, and now we'll talk about the many types of cryptocurrencies. So we said Bitcoin was an open source code. Open source code means you can copy it. You can copy it and make all sorts of copies of that code. Facebook is not open source. You can't copy Facebook, right? You can't get the source code of Facebook or Twitter or whatever. But you can get the source code of this massive financial system code, and you just copy it. But there's some issues around that. But what's very interesting is that we mentioned Bitcoin, we mentioned Ethereum. There's other ones. Ripple is very important. It's a startup in the San Francisco Bay Area. They recently raised another $55 million. It was, I think, their third or fourth round of funding, $55 million US dollars. And they're doing lots of experiments with banks. Recently in Japan, they've put together about 33 some odd banks that were doing settlement. They were doing remittance, essentially. And they plan to take it globally to make a global remittance system. I'll talk about Monero as an interesting system where you don't see the transactions. Like we just looked at the Block Explorer and we saw the transactions and the amounts. You don't see those in Monero. And interestingly, it's got a market cap of about $288 million. So these are the total values of all the coins in these networks. And Zcash at the bottom is similar to Monero. I think JP Morgan Chase Bank invested into Zcash. They use something called ZK snarks, or zero knowledge proofs. Being able to calculate all of the coin without knowing the transactions and who owns them in the network. It's very profound what they've done there. So there's literally hundreds and hundreds of cryptocurrencies. Imagine STC having a cryptocurrency, at least to play with. Citigroup experimented. They had 3 different cryptocurrencies. I took a team to Emphasis in India. On the spot, they created InfiCoin, INFY, InfiCoin, Emphasis Coin. And so they could start playing with it to see what it was. You can go to CoinMarketCap. That's an extra credit. Check out the various types of cryptocurrencies. You'll see dozens and dozens of theirs. We haven't talked about this, but this is so true. Well, a little bit with the smart contracts. This is programmable money. How can you program money? You can program lots of things. IoT devices, printers, right? You can program telephones. You got apps on phones. But how do you program money to do what you want? For instance, imagine you had STC coin, and I had an STC line, and I made a phone call to you, and every second, could be every minute, a tiny fraction of STC coin was leaving that phone and going back to the network, every second. Every app download of some sort, there was STC coin moving without real human interaction. Program into the app. That's profound stuff. Dan Moorhead created Pantera Capital to invest in Bitcoin startups based in the Bay Area. He was looking at all of the internet protocols over the years. Like we all figured out what that protocol HTTP was, and even my mother knows what the difference between HTTP and HTTPS. Secure HTTP, oh, wow. Or secure